Proving identities using fundamental identities. You know, there is a lot of identities in trigonometry, and in fact, this part will occupy much of the time in trigonometry. You will devote weeks for this topic. Example 3.35, simplifying expressions using odd and even identities. Or this is something like also about proving. So prove that the square of cosine of x times the square of tangent of x is equal to sine of, or the square of sine of x. Because this one says prove, okay, so what you do first is you write the word prove. Show your proof that this identity is true. Okay, so what do you do? Okay, so cosine, the square of cosine of x times the square of tangent of x, okay, that is equal to, okay, so this is where your fundamental identity will come in. The square of tangent of x is equal to sine of x divided by cosine of x, and all of that squared. All of that squared. And so you can write this as the square of cosine of x times the square of sine divided by the square of cosine of x. The square of cosine of x divided by the square of cosine of x is equal to 1. And so we have shown that this expression is equal to the square of sine of x. And you will finish your proof with this symbol. Okay, so this means your proof is done. So it is true that this one is equal to the square of sine of x. Okay, so let's do the letter B in another page. Prove that 1 minus secant of x times the cube of cosine of x is equal to, again, the square of sine of x. You write the word proof, and let us see. How will this appear or look when we apply some fundamental identities? So 1 minus secant of x times cosine. The cube of cosine of x is equal to, you know that secant of x is equal to 1 over cosine of x. And then times the cube of cosine of x. And so you will apply the laws of exponents. The cube of cosine of x divided by cosine of x is the square of cosine of x. And you know this to be equal to the square of sine of x. Okay, so that's how you do it. That is how you write a proof to verify identities.